Right, I'm going to write these numbers down. So we've got the positive number integers from 1 to 6. And then we've got p additional 5s. So I just keep adding, putting on additional 5s, and it's p times. And then we've got q lots of 7 to finish off. We don't know how many 5s and how many 7s there are here. We just know we've got p lots of them and q lots of them. But we are told that the mean of all the numbers is then 5.3. So we need to work out the mean, and that involves adding them all together. If I add these together, then I get 3, 6, 10, 15, 21. So the sum of this is 21. So the mean is going to be 21. Now I've got p lots of 5, which means that's the same as 5p. I just times the 5 by how many I have. I have p lots of them, so it's 5p. And then I have q lots of 7, so similarly it's going to be 7q. Now, how many terms do I actually have? Well, I've got 1, 2, 3, 4, 5, 6 numbers here. And then I've got p lots of 5, so I'm going to have to add p, and then q lots of 7. And this is equal to 5.3. I'll write it as 5.3 for the moment. I don't think I really want a decimal in there, so I'll get rid of that in a minute. In fact, I'm going to write it as 53 over 10. Now I can do some cross multiplying. I can times both sides by 10, and I'm going to times both sides by 6 plus p plus q. I actually can't remember what I'm trying to do at the moment. I'm just trying to find the smallest possible value of q. Okay, let's try and get there. So I've got 10 lots of 21 plus 5p plus 7q, and that is going to equal 53 lots of 6 plus p plus q. We've got an equation without any fractions in involving p and q. Multiply this out, so 210 plus 50p plus 70q is equal to 318 plus 53p plus 53q. I'm going to minus the 53q from both sides. So, and then I'm going to minus the 210, and I'm going to minus the 50p. So I'm going to do all that in one go. I'm going to get 17q on the left-hand side from minusing 53q. And then I'm going to minus 210 from both sides. So this will become 108, and it disappears on the left-hand side. And then plus 3p. So I've got an equation involving q and p that's as simple as we can get, really. Now, there's a few ways to deal with it from here. Remember, we're trying to find the smallest possible value of q. That really helps that 3 goes into 108. So if we divide 3 by 3, then we get 17 over 3q is equal to, and we need to do 3's into 108. I know it goes into it because it's the digits add to 9. So it's going to be 3, 6, 36 plus p. And therefore p is going to be 17 over 3q minus 36. So this helps because remember q has to be an integer, so q must be a multiple of 3. And remember p must be greater than 0. So if we tried, for example, if we tried that q was just 3, then I would get 17 minus 36, which would be minus 19. That's not going to work. Can't have minus 19 lots of 7. Or is it minus 19 lots of 5? Right, some more multiples of 3. Well, we could go with the next one, 6. So then I'm going to get 34. I'm going to get minus 2. Okay, that still doesn't work, but we look like we're nearly there. So the next one will be 9, and then that's going to work. I'm going to get 51 minus 36. I think I'm going to get 15. So that will be okay, and that will be the smallest possible value for q. Yeah, I'm not quite done. I just want to talk about another method that you could have used. Like this is the best method because you can divide 108 by 3 and you just get like a nice, you just need to check if it's a positive integer. Let's say you didn't spot that, you could have resorted back, to this 17q is equal to 108 plus 3p. And then you could try different values of p until you get a number that's divisible by 17. Now that's quite awkward because like 17 is not particularly nice and you'd have to write down your times table and so on. But let's say we try p as 1, then we'd get 111. Of course, I'd have to keep going here. So 68, 85, 102, 119, and you see it's not enough. And then we'd be going up in threes every time. So when p is 2, we get 114 and so on. We actually know the final answer was p is 15, so you'd be going for some amount of time unless you notice. I mean, probably the best thing to do is to keep going and then be able to spot it. So and then we get it's 153 and I can look for a multiple of 3 that I could add on to 111. So I'd have to add on 8 to get to 119, so that's not going to work. I'd have to add on 25 to get this one, so that's not going to work. But here I'd have to add on 42, and that would work. So that would be a slightly better way of doing it. We could say, all right, how am I going to add on 42? Or sorry, actually I'd add on, it would be 45 to 108. So that's why it'd be 15, because it would be 108 plus 3 times 15. So there are shortcuts even within this longer method. And actually this is how I did it. But like I said before, sometimes you've got to think carefully. And I should have thought carefully about which one to go with. And in this case, it's better to make P the subject first.